The other thing that we discussed in the last lecture was a classification of the different states of a Markov chain into different types. A Markov chain in general has states that are recurrent, which means that from that recurrent state you can go somewhere else, and then from that somewhere else you can always come back to it. So if you have a Markov chain of this form and you start in state 9, the options for you is to either go to state 3 or to state 5, but no matter what, if you go to 3 you can come back always, and if you go to 5 you can always come back as well. So clearly 9 here will be a recurrent state, and 3 for the same reason, and 5 as well. Now if you look at the state 6 or 7, it is the same thing. Starting from 6, the only way that you can go to is either stay at 6 or go to 7, and then in that case you always come back, and same thing from 7. You can either go to 6, that's it actually, and come back. So both of these are recurrent as well. So in a case a state is not recurrent, we will call it transient. So let's look at, for example, state 1. From state 1, if you go from 1 to 2 and then go to 6, there is no way to come back to 1. So the state 1 is transient, and for the same reason the state 4 will be transient and the state 2 will be transient. What about 8? Well, the same reason, the state is transient as well. So what we have seen also is the notion of a recurrent class. A recurrent class is again a collection of recurrent states that can communicate between each other. So here for this specific example we have two classes. This is one class, right? So it's a class 1, right? Let's call it recurrent class 1, and this is a recurrent class 2. So here again we have two classes instead of one, because if you are in one of these class, there is no way that you can find a path to go to one state here, and vice versa. If you are in one of these states here, there is no path that would lead you to that recurrent class. Now in the case where you have two recurrent classes, like here or more, it is pretty clear that in the long run the steady-state behavior of the Markov chain will really depend on where you started. So for example, if your Markov chain started in that recurrent class, there is no probability that in the long run it will be in that class. And vice versa, if it started here, the probability of being in that recurrent class in the long run is 0. So the long run behavior of the Markov chain will depend on the initial condition. In the case where you have only one recurrent class, let's forget about that portion, for example, and you have only that portion here, then maybe the initial condition will not matter in the long run. But in fact, it's not going to be always the case, depending on the recurrent class being periodic or not, as we will see in the next clip.